Hey everybody, let's greet each other properly. Good morning, this is Mr. Ainsworth here. Oh yeah, and I'm a little bit away from you guys right now because I am on a trip to go see my parents and spend some time with them on their 80th birthday. So I'm preparing this for you guys. Okay, so here we go. So we're in section 9.3 here in financial algebra. All right, here at Great Oak High School, just in case you're watching this from somewhere else. All right, that's possible because these videos go everywhere on the internet. All right, and we're going to be talking about supply and demand here and about a few other concepts too, about how things are affected, and how things are priced and how things are marked up and down, okay, according to different situations. So get your red pen out. We'll put the key points in red like we always do. We'll use decimals off to the right for our computing, and we'll work through it here. So just go at your own pace, pause and play. All right, and if you're using this as a checking tool, just advance it to whatever you're checking, and then go for it. So let's get on it. Wayne, number one here, Wayne's Widget World. Sells widgets. Okay, widget is just a general term for an item, okay? That could be any item that's being produced, like a Microsoft pen. It could be a whiteboard marker. It could be a pencil. It could be a car. It could be anything that's produced in a factory. All right, so we're selling widgets here to stores for $9.20 each. That's the wholesale price. Okay, so this is the wholesale right here. Okay, a local store marks them up. Okay, marks them up $8.97 because they need to make some money, right? Okay, so Widget World sells it to the store marks it up, sells it to you. The question is, what's the retail price? So main concept number one for the day, and let's put this in red, the retail. Okay, retail price. All right, and this goes for anything. Okay, the retail price is equal to the wholesale price plus the markup. Okay, so the wholesale price, okay, plus, all right, the markup in dollars. And I'm not talking about the markup percentage, I'm talking about the markup, whatever that is in terms of a dollar amount. Okay, key concept number one. And so the retail price here, which is what they want here, so retail price is going to be equal to $9.20, all right, and then plus the $8.79. And as in anything, you guys need to work through it here. So work through it. Okay, just put that in there and go for it. So $9.20 plus, right, the $8.79. Boom, 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 boom. You get $17.99. So once again, you just work through the lesson here. All right. If you can do it in your head, great. If not, then use your calculator. Okay. So $17.99. There is the retail price, and that's what a customer like you and me would have to pay at the store. Okay, so the local store has to make the money, and the way they make some money, i.e. some profit here, is they buy an item, then they mark it up, and they sell it to you, and they make what's called profit. Okay, the markup is the profit to the store. Now number two is an algebraic one. Okay, so let's read it first. The wholesale price of an item is W dollars. Okay, so we know what the wholesale price is. It's W dollars. Okay, we know that. All right, the retail price is P% higher. Okay, P% higher express the retail price algebraically. So we're going to basically do the same thing. The only thing is we have to figure out what the markup is, because it doesn't give us a markup, it gives us a percentage. Okay, so the first thing what we need to understand is we're going to take this right here off to the side, P%, and we're going to write P% as a fraction. Okay, and percent means per 100, so P% is P per 100. All right, that's the first thing. Second thing is that we need to know how to calculate a markup in dollars given a percentage. So this is key concept number two. So let's write a little formula down here somewhere. So number two, key concept number two, we'll say the markup. Okay, no, this is not a problem number two, it's just key concept number two. So the markup right here in terms of dollars, okay, it can be found always by taking the percentage by the wholesale, multiplied by the wholesale price. So the markup percentage, again, put this in red here, multiplied by your wholesale price. Okay, so that's how you calculate it. So the markup in our case is just P% times the wholesale price, which is W dollars. So in this case, the markup is equal to W dollars, okay, which is the wholesale price times percentage. All right, in numerical form, so we've got to divide that by 100. So P divided by 100, there's your percentage, times the wholesale price. It says W dollars right here, wholesale price. So times W, okay? And that's P times W divided by 100. And that's the markup. That's the first part of it. Now, to express the retail price algebraically, we've got to take the markup here, which is in dollars, okay? So PW divided by 100 is in dollars now. And we got to add it back to the wholesale price. So step 2 on this process here, okay, so this tells me now, let's just enlarge this because we don't need a calculator on this one here. So the retail price is now, again, look at the very top, wholesale plus markup. So the wholesale price is W dollars plus the markup, which we just calculated right here, all right? And so that's PW divided by 100, and that's in terms of dollars too. All right, dollars plus dollars equals $200. So if we actually knew what W was, like 20 bucks or whatever, and we know what the percentage was, like 2%, 3%, 4%, we can just plug those values in and we get the retail price. That's it. And so remember, concept's the most important thing. So make sure you put all your formulas that I'm writing in red here. Make sure you highlight them because that is what you're going to apply to different problems in the future. Okay. Let's go to number 3. Number 3, the Noki Corporation sells hockey sticks, Noki hockey, at a wholesale price of 103 bucks. If the store marks this up 106%, what is the retail price? All right, so we can do this in 1 or 2 steps, but if we step it out, it kind of looks like this. So first of all, I know that 106%, all right, is equal to 1.06 as a decimal. Okay, just know that. Now we need to figure out what the markup is. So let's figure out the markup. So step 1, markup in terms of dollars. All right, and as I just said right here, it's markup percentage times wholesale price. Well, the wholesale price is $103. That's what it says in the problem. It says right here. Okay. Okay, so what we're going to do is we're going to take the percentage multiplied by the wholesale price. So we're going to take the percentage, which is 1.06. Oops, sorry, 1.06 multiplied by the wholesale price of $103, and we're going to get some dollar amount. And obviously, 106% of 103 is going to be bigger than 103. All right. So what is this number here? All right, so we're going to take 1.06 times 103, and notice it's $109.18. So this is right here, oops, this is the amount markup is going to be, that's happening here. So it's going to increase the price $109.18, okay? So now the retail price, retail is equal to the wholesale plus the markup. Now the wholesale price is 103 bucks, the markup is 109.18. All right, and you simply add these together. You add the results. So take 103, add it to 109, all right, 0.18. All right, so, and you get $212.18. And that's what it's going to be to the consumer. So $212.18. So 2-step process. Find the markup first, add it to the wholesale next, boom, you get the retail price. And you guys, this is what happens in stores everywhere in the world, okay? Because the retail price is always greater than wholesale because whoever's selling it, the retailer, needs to make a profit. All right, everybody needs to make money because it costs money to make money. Okay, there's a lot of what's called overhead in any business, and you have to mark up your product, whatever you're selling, to make money in order to pay for everything that it takes to run a corporation. All right, number 4. So in this one here, a tire company sells bicycle tires to retailers for $T. Okay, Mineola Bike Shop marks them up 80%. Express the retail price algebraically. Okay, so let's work this out. So we can figure out the markup. If we approach it just like a number 3, we can step it out in 2, and then I'll show you how to do it in 1 step. Okay, so the markup first. So step 1, markup, just like we did before on number 3. So that's going to be equal to the 80% times the retail. So tire company sells bicycle tires for $T. So what we're going to do is we're going to take 80%, so 0.08, multiplied by t dollars, and we get 0.8 t. All right, and that's in dollars. Okay, so now what we need to do is we need to add that to the wholesale price. So the retail is always the wholesale plus the markup. So we take the wholesale price, which is t dollars, and add it to the markup, 0.8 t dollars. And if you know that t is the same thing as 1t, you take 1t plus 0.8 t, you get 1.8 t, whatever t is. Okay, t is in dollars. And this is in dollars, okay, dollar sign. Now you can do it the two-step process, or what I like to do, okay, here's a fast way of doing things right here, so just check this out. If you're going to mark it up 80%, then really the retail price is going to be, it's going to be 180% of the original. So you take 100% of the product plus, and you're going to mark it up 80%. So the new price is going to be 80%, 180% of the original, okay, or of the wholesale price. Wholesale price, WP is wholesale price. So what that means is that you got to take 180%, okay, multiply it by the wholesale price T, and that is 1.80 T. And by the way, that's the same thing as we just got. So typically I do it this way here. I just add the percentage markup first to 100. Because if you're marking it up 80%, then obviously you're over 100% of the original. So it's 180% of the original cost or price. And then you just take 180% of the wholesale price. One-step process there. Okay, so there's two ways to do that one. Number 5. The following graph shows supply and demand curve. You guys talked about this in your economics class, okay, for a widget. And again, a widget is just a product, okay? It could be anything. All right, and so we got this supply-demand curve here. We got if you just look at the graph right here, price, okay, this stands for price here. This price is on the horizontal axis. Q stands for quantity. Okay, that's on the vertical axis. So Q stands for quantity, or how many you sell. Q, okay. And then so P stands for prices on the horizontal. So these are in dollars here on the horizontal, and then you got quantity on the vertical. And you got the supply versus demand curve that you guys we're talking about in economics with your economics teachers. And here we are in financial algebra talking about the same thing. Oh my God, here we go. So hopefully this backs up or makes everything more understandable compared to your economics classes. So it says explain what will happen if the price is set at $9. Okay, so let's take a look at that. Okay, all right, so the question is, well, let's figure out, let's plot $9 first. Okay, so let's graph $9. Where's $9? So if this is 0 and this is 5, and then over here is 10. Okay, so this is 10 right here. So 9 is a little before 10, so 9 is about right here. Okay, that's approximate. So what will happen to the price, or what will happen if the price is set at $9? What will happen? Okay, so let's take a look at the curve here. Let's draw a vertical line through 9, and let's see where it intersects the graph. So I'm going to do that. So go straight up. No. So straight up here. No. And figure out where it meets the two curves. So if you draw that, it meets the demand curve down here, and at point, let's say A, and then it meets the supply curve at point B. Okay. So what that means is that the demand right here, in terms of quantity right here, is going to be less than the demand. The supply is less than the supply. So what in the world does that happen in terms of the real economy? So if you go to the left here, it's going to go at point A and just go to the left. You notice that it gives you a value here on the vertical axis, the quantity axis. And if you go from point B to the left, you'll notice that its quantity for the supply is going to be much greater than the quantity for the demand. All right, so here the supply is, you can say it's greater than demand, or you can say that demand is less than the supply. You can say that either way. So if the price is set at 9, all right, there would be more than enough supply to meet the demand because the supply is greater than the demand. So okay, so let's just make a couple notes right here. So at point B here, if you compare points B and A on the graph right here, so first of all, supply is much greater than the demand. So first, all right, the supply, and in terms of quantity, right, this is just the amount of whatever product you're talking about right here. So supply of the product, in this case it's a widget, all right, the supply is much greater than, all right, the demand. The demand of the public wanting this widget, right? Well, I don't know what the widget is, but whatever it is, all right, there's more widgets than what people want to buy. That's what's really going on here. And so what happens is there is a surplus. Okay? Okay, and this is not a good situation here. So now we have a surplus of widgets. We have too many widgets because there is less people wanting to buy the widget compared to what the supply is out there. All right, and that's going to affect things, okay? And when that happens, if there is a surplus, if there's a surplus of goods, which is what's going on here. So let's write that down. So this means that there is surplus. So there is a surplus, which means more than enough, okay? A surplus of widgets. Okay, too many. That's what I'm talking about here. So too many right here. What's going to happen, it's going to drive the price down. Okay? That's what's going to happen. So it said, explain what will happen if the price is set at 9. Okay, so the supply is going to be greater than demand, which means that there's a surplus, okay? Not a excess inventory here. There's a surplus here, not a what do you call it? Lost the word here. So not a shortage, but a surplus. Okay, that's what so it's the opposite of a shortage. All right, so there's a surplus which drives the price of the product, or in this case, the widget, down. Okay, so the net effect. So let's write down the effect, because it says what happens. Well, the effect, okay, it drives the price down. All right, so that people will buy it. So if you bring the price down, okay, probably more people are going to buy the item, in this case the widget, because obviously people don't want to spend more, they want to spend less. So the question is like, what should the price be so that the supply meets the demand? Okay, what should that price be? And in this case, the price is too high, so the demand is low, and there's going to be a surplus of goods. And that's not good, because if there is a surplus of goods and they're perishable, let's say avocados, for example, if there's like, go to Stater Brothers or Albertsons and they put too many avocados on the shelf, okay, knowing that they only last for a few days before they become overripe, they're going to lose that produce, and there's going to lose out on money and revenue overall. Because if they set the price too high, not everybody's going to go buy those avocados. Whereas if they bring the price down, the people are going to buy more avocados, and it's going to decrease the inventory on the shelf. So just keep that in mind. The price can't be too high because people won't buy it, and it can't be too low because then the company won't profit. Okay, so there's got to be this special price that is good for the company but also good for you. Okay. Now it says use the graph to explain what will happen if the price is set at 275. So let's graph that here. So 275, so if this is $5 on the horizontal, half of that is 250, a little bit more than half. So let's say this is 275. Okay, this is part B. So okay, so draw a vertical line and see where it intersects the graph. Okay, so it intersects at two different places. So it intersects at point C. Okay, and it intersects at, oops, I missed that one. Intersects at point D. So it intersects the supply curve at C, intersects the demand curve at D. Okay, so what's going on here? So if you set the price at 275, let's first figure out what we notice here. So in this case, if you go to the left of C, okay, it has some certain quantity, and then if you go to the left of D, now notice there's a higher quantity. So here at point D, the demand is going to be obviously greater than the supply at point C, because obviously when you go higher up on the y-axis, you're going to have a bigger number there. And again, that doesn't include units here. We don't know, but I just know that D is higher than C. Okay, so the demand is obviously greater than the supply. So that's the first thing we notice. All right, so the first thing we notice, okay, is the demand is much greater than the supply. So demand is much greater, okay, than the supply. Which means there's not enough inventory. There's a shortage, okay? So there's a shortage of widgets. Okay, so there's a shortage of widgets. Now remember, widget is a general term for just a product being produced in the factory. Now having a shortage of widgets is not good, because if they don't sell enough, they're not going to, the company's not going to profit. So, and then everybody's going to be upset because there's not going to be enough of the widgets, right? Or in the avocado case, if you sell them too low, there's going to be people are going to come in and buy 5, 10 avocados because the price is so low, and then not everybody's going to get an equal share of the avocados, right? Because there'll be a short of avocados because the demand is so high. Okay, so in this case, what's going to happen? Okay, so in this case, there's not enough supply or inventory to meet the demand. Okay, so that's the second thing. So I'm just going to make note of these things. So, okay, there is not enough inventory because, again, the supply is less than demand. So that means there's not enough inventory, all right, to meet the demand. And what's going to happen? Well, it's going to force the price up as opposed to down, okay? So this is going to drive the price up. So this arrow means imply. So what happens, or this affects, the effect is that it drives, okay, the price up as opposed to down. It's going to try to meet that special equilibrium point where the supply meets demand. That's where the supply is just the right amount that the people will buy it, and that point always happens at what's called the equilibrium point. Okay, that's the net effect. Okay, so there's your first taste of a supply and demand curve. Unless you saw it in economics, of course, then you probably already know this. All right, let's move on. Number 6. Again, I'm taking you through the lesson here the best I can, being online here since I'm out of town. All right, number 6, what's going on? An automobile DVD navigation system sells to stores for a wholesale price of $4.97. Popular national chain sells them for $870.98. What's the markup? Okay, well, that's a pretty easy question here, because the markup is how much over the original, or the dollar amount over the wholesale price. That's the markup. It's whatever the retail price minus the wholesale price is. I mean, that should make sense because I said that earlier up here at the very top. Okay, so if the retail price is equal to the wholesale price plus a markup, then the markup must be whatever the retail price is minus the wholesale price. So let's go ahead and write that down. Okay, so key concept number 3 today in red, okay? So the markup is going to be equal to the retail price, which is what we're given here. So the retail price, all right, minus the wholesale price. So for in this problem here, okay, we take the retail price of $879.99 and we subtract the wholesale price of $497, and then you get a number there. And if you just subtract, do the arithmetic here, you're going to get $382.99. Okay, just subtract. Pretty simple problem. Okay. Number 7, a guitar sells for a retail price of G dollars. All right, the wholesale price of the guitar is W. Okay, so let me see here. So wholesale right here. All right, W. All right, retail price right here is G. Okay, so now we're given that, and we want to write an algebraic expression, all right, for the markup and expression for the percent of the markup. Okay. All right, so let's do that. You know, we're not going to be testing on this. Really focusing on this on the exam. So you know what, to save time in the video, because I don't have a whole lot of time before I go out of town. So you know what, I'm going to skip this temporarily here. I might do it later on, but I'm going to skip this. We're going to go on to an actual numerical problem here, because this is just an algebraic one here, and I'm just going to focus in on the algebraic, the numeric. All right, so let's shift to number 8. All right, so here we go. This is an actual numerical example. So an automobile ski rack is sold to stores at a wholesale price of $38. If a store has a $23 markup, what is the retail price of the ski rack? Find the percent of the markup to the nearest percent. So we need to do two things. Okay, two things. So let's figure out the retail price first. Okay, so so number 1 right here, retail price is number 1, and then number 2, find the percent of the markup. Okay, so let's do number 1 first. All right, retail price again is equal to the wholesale price plus the markup. So that's the easy part. Okay, so retail, all right, is equal to the wholesale price, 30. It says right here, $38. So $38 plus the markup. Okay, that's given in the problem too. So plus $23. And so that's going to be $50 and $11, $61. Okay, so that's the retail price. Now, number 2 says find the percent of the markup. Percent of markup. Now, you got to remember, percent markup is a percentage, and percentages are always taking the portion or the part divided by the original, or the original price in this case. All right, so the percent markup in general, so percent markup, I'm going to write it in red here, all right, is always equal to the markup in dollars divided by the original price. Okay, so the markup in dollars, all right, dollars here, divided by the original, or what's called the wholesale price. You can say original price, wholesale price, same thing. You know, what it costs coming out of the factory. Okay, so for this one here, the markup is $23. And the wholesale price is $38, and all we have to do is divide the two and get a decimal. All right, and we can figure out what the percentage this represents. You know, what percent? You know, I don't know. So let's calculate this. Okay, so here we go. So we're going to take 23, all right, and divide it by 38. Boom, right there. And when you change it to percent, you simply multiply by 100, and we're going to get 60.5%. Okay, so 60.5%. The book says about 61%. That's fine too. You can round. Okay, so about 61% markup. That's what this $23 represents. It represents a 61% markup. Quite a bit, actually. All right, 61% approximately. Okay. Moving right along. Hopefully you guys are getting this. All right, are you? Is it making sense? You know, tell the person next to you, is this making sense? You know, everybody say something right now. I'm not here with you guys, but tell the person next to you, is this making sense or not? Or is this just, it might just, you know, is this a bunch of gibberish? I don't know. Hopefully it's making sense. These are realistic stuff here, guys. Okay, now number 9. Ooh, okay, here we go. Okay, everybody say ooh. Okay. Number 9, manufacturer takes a poll of several retailers to determine how many widgets they would buy at different wholesale prices. The results are shown. What is the equation of the demand function? All right, the demand function, use the demand function to determine how many widgets to the nearest 100th retailers buy at a price of 120. So we got a couple things here. Okay, so what is the equation of the demand function? That's number 1. Okay, no, right there. Okay, so we have to figure out for part A right here, the first part here, your demand function. Guess what? We're going to approximate it using what's called linear regression. Okay, so linear regression, we've done this before. So we're going to do it again. Okay, so that's y1 approximately equal to mx1, all right, plus b. So we're going to enter that data into Desmos here, and we're going to figure this out. Secondly, we're going to use the demand function here. So number 2, use the demand function to determine how many widgets at a price of 20, because guess what? It's not in the table right here. So if I add it right here, 20 bucks, or you can put it over here on the left, doesn't matter, you know, what would it be? Okay, how many retailers will purchase, you know, what would the quantity of cups, no, excuse me, not cups, what would the quantity be, you know, if we set a price at $20? Would it be more or less than any of these values here? All right, so let's do it. So let's go to Desmos here, and we're going to have to enter the data in. So here we go. So add in a table. And by the way, when you do this right here, you're going to put the x values in first right here. So the quantity depends on the price. Okay, so y and x right here. So here we go. So 23. Let's see if we can do this. 26, 28, 30. Let me see. They don't all go by 2, so be careful here. So 28, 30, 33, 35. So 33, 35. Just keep going. And then 37 and 40. All right, let's put the other ones in. All right, so be careful when you enter these values in here. So it's very easy to hit the wrong keys on the keyboard, so be careful. Double check your numbers. I'll have to double check when I'm done here because I'm talking and typing at the same time, so it's probability of making a mistake is pretty high, so you got to be careful. Okay, so hopefully I got that right. So let me just double check. 23, 4,000. I'm just double checking right now because I'm talking and typing at the same time. Not easy to do. All right, now let's figure out the linear regression line. So type in y1 is approximately equal to mx1 plus b. Okay, there we go. So what we need to do here is we need to bring this into our lesson here. So let me do this. Let me screenshot this data here. And let's bring that into our lesson. All right, so in respect to number 9, there we go. All right, so the equation here, we got the slope here, we have the y-intercept here, okay, and what we need to do is take this information and substitute it in our function. So y is going to be equal to negative 155.876 times x, all right, plus 7,428.85. All right, there's our linear function, and what we're going to do is we're going to write that in here in Desmos. We're going to type it in, actually, not write it, but type it. So go ahead and enter it in as y equals negative 155.876. All right, make sure you multiply it by x, and then add the y-intercept of 7,428.85. Okay. And what I'm going to do is I'm going to duplicate that and make it a table, and then what I'm going to do is I'm going to delete all these values, and I'm going to enter in 20 because I want to know what the demand is, or excuse me, how many widgets we need to purchase, and or would we purchase if we set the price to 20. Okay, so we're going to set the price to 20 and see what happens. So I'm going to type in 20 here, and notice that we have a value of 4,311 widgets. Okay, so if the price is, if we set the price to $20, that would give us y is equal to 4,000. Looks like 311. The publisher says 4,300. They're rounding. Okay, this is nearest 100 here, so this is approximated as 4,300 widgets. All right. Excuse me. Yeah, they're widgets. Okay, general term again. That's kind of like a business term. All right. So if we set the price to $20, then demand would be 4,300 widgets. So the price determines the demand, okay, or has an effect on the demand. So you want to adjust the price accordingly. Too low, the demand will be too high. Price too high, the demand will be too low, because no one wants to buy anything that's way too expensive. Okay, make sure you save your work too, because you're going to have to submit this. Okay, that is number 9. All right, and what you guys need to do is figure out the rest here, okay, on your own. So I'm going to stop the video here, actually, because number 9 and 11 are very, very similar. So this one's similar, all right, to number 11. All right, so keep that in mind down over here on the next page. And then number 5 and 10 are similar. Okay, so let's go back up to number 5. This is similar to number 10. All right, here. So just keep that in mind. So use what I talked about in number 5 to help you out with number 10, because it's another supply and demand curve problem. And then use what I talked about in number 9 to help you out with number 11. All right, and do your best. Check your work with the publisher here and do the work together. You guys are in groups here, guys. Holy cow, look at number 11. Number 11's got a lot, big work. So if you have any questions on any one of these here, go ahead and mark the ones you have with question marks, okay? Like if you don't remember about correlation coefficient, talk to your group. Figure it out. And if your group can't figure it out, I will talk to you about it on Monday when I return, okay? So again, all of these things like correlation coefficient, the word extrapolation or interpolation, all right, you can Google these things, all right, Google words for definitions. So just don't stop and everything. Go ahead and research this, okay, because it's been a while since we talked about linear regression line, correlation coefficient. If you don't remember what extrapolation and interpolation is, okay, fine. Google it, check it out, because this idea here is not that hard. All you have to do is know the definitions. So research it, and then again, work in groups, all right? And number 1 and number 2, give your best effort. Give your best effort, okay? Just because I'm not with you guys doesn't mean you can't give me your best. So give me your best, and I will see you when I get back in class. All right, and this is Mr. Ainsworth here. All right, I hope you guys are doing well. I miss you guys, and I will talk to you soon when I get back. Take care. Bye-bye.